The next lesson that we're going to talk about is quotients, and we're dealing with our exponent properties. So the first objective is going to be to divide powers with like bases, and then our second objective is going to simplify algebraic expressions that have negative exponents in them. So to begin, I want to review what the quotient property of exponents says. So the quotient property of exponents. And it says this. It says you have x over a over x over b, and the bases are the same, then you could subtract the exponents. So it will become x to the a minus b. Okay? So in words, this says to divide with like bases, subtract the exponents. Let's look at an example. Example 1. We're going to look at 32 a to the third divided by 4a. Okay, so the division operation, remember we can rewrite that as a fraction. So we have 32 a to the third power over 4a. Okay, so I'm going to explain to you why this property works. Because 32 times a to the third power is 32 times a times a times a, all over 4a. Well, we can reduce, right? 4 goes into 4 once, and 4 goes into 32 8 times. And then a divided by a is just 1, so those cancel out, leaving us 8 times a, which is 8a squared. And then 1 times 1 is 1, so 8a squared over 1, which is just 8a squared. Okay, so this is our answer right here. We could have done it the other way. We could have said, well, 32a cubed over 4a squared. Well, I'm sorry, 4a, not a squared, just 4a. Well, that a has an exponent of 1, and I know that 4 goes into 32 8 times, and these are like bases, so it's going to be a to the 3 minus 1. So I get 8, and then 3 minus 1 is 2, so 8 times a squared. So we get the same answer whether we go ahead and just simplify by canceling, or if we use our quotient property, we still get the same answer. Let's try another example. Example 2. So for example 2, we want to simplify 24 x squared y to the 6th and then z to the 7th all over negative 8 x y to the 2nd and then z to the 5th. Okay, so first of all, 24 divided by negative 8 is going to be negative 3. And then we have x squared over x. Remember, x has an imaginary exponent of 1. So this is going to become x to the 2 minus 1. And then we have y to the 6 over y to the second. So this will become y to the 6 minus 2. And then we have z to the 7th over z to the 5th. So that will become z to the 7 minus 5. Okay, so our final answer, we've got -3. X to the 2 minus 1 is 1, so x to the 1, and we can just leave it as x. And then y to the 6 minus 2 is 4, and then z to the 7 minus 5 is 2. So this will become our final answer. All right, now to review another property. I want to recall the negative exponent property. That's our next property we're going to talk about. So, negative exponent property. Which says this. It says that if you have x to the negative n power, your exponent does not want to be negative. So we'll take the reciprocal, so it'll become positive. So it'll become 1 over x to the n. If it was a negative exponent in the denominator, then that base and that exponent would move to the numerator. So basically, your negative exponent is going to move either to the numerator or to the denominator, so it can become positive. Okay? So let's do a couple of examples, and on these examples, I want you to remember that that there's also another property that we need to remember. We need to think about, let me show you the example. This is example 3. If you have x to the negative 4th and y to the 2nd, what we need to remember that the only thing that moves is what is connected to the exponent, whatever the base is connected to the exponent. So for example, for this x to the negative 4th times y to the 2nd, the only thing that's going to move is x to the 4th. So y to the 2nd is still going to stay in the numerator, and in your denominator you're going to have x to the positive 4, because when he moves, he becomes positive. All right, let's look at some more examples like that. Let's do part B. So this one is going to be 2 to the x to the negative 2. So again, very important to remember, the only thing that's moving is what's attached to the negative exponent. So the 2 will stay in the numerator, and then the x to the negative 2 will move to the denominator, but will become x to the positive 2. Okay. So let's do another example. This one we have -3 x to the negative 2 and then to the 3rd power. Okay, so for this one we have to distribute the 3rd power. Okay, so it's going to become -3 to the 3rd power, and then x to the negative 2 to the 3rd power. Okay, well, we know that -3 to the 3rd power is -3 times -3 times -3. So -3 times -3 is +9, but then 9 times -3 is -27. Okay, and then we have x to the negative 2 times 3, so that becomes x to the negative 6. And lastly, we need to take care of our negative exponent. So he's going to move, but the negative 27 is going to stay in the numerator. And then x to the negative 6 will move to the denominator. However, it'll become x to the positive 6 now. All right, let's do another example. We have 1, not equals, we have 1/3 x to the negative 3 to the negative second power. Okay, so that negative second power has to be distributed. Okay, so we're going to have 1/3 to the negative second power, and then we'll have x to the negative third power to the negative second power. So this 1/3 to the negative second power, it still has to be distributed, okay? So what's going to happen is that we will have, it's going to be distributed to the numerator and the denominator. So it's going to come 1 to the negative second power over 3 to the negative second power, okay? And then this x to the negative third power to the negative second power, that's going to be multiplied, so we'll get x to the negative 3 times negative 2 is positive 6. Now we have to take care of our negative exponents. So 1 has a negative exponent and 3 has a negative exponent. So the 1 to the negative 2 is going to move to the denominator, and it's going to become 1 to the positive 2. And then 3 to the negative 2 is going to move to the numerator and become 3 to the positive 2. Okay, and 3 to the positive 2 is 9. We still have x to the 6th. And then 1 to the second power is 1, so we can just leave it as a 1. And anything over 1 is itself, so we have 9x to the 6th. All right, so let's talk about the zero property rule now. The zero exponent property. Which said that anything to the 0 power was 1. And so, because of that, if we are using our quotient property and we have something like this, let's say we have x to the third power over x to the third power. Well, using the quotient property, that is x to the 3 minus 3. Well, 3 minus 3 is 0, so we get 1. Okay? So that is super helpful. It also, x to the third over x to the third, anything divided by itself is 1. So again, it makes sense, even if we're just using canceling, to show that anything to the 0 power is 1. All right, so let's do an example where we have to divide, and we have to express our answer in positive exponential form. So to put it into positive exponential form, that just means that we can't have any negative exponents. That's what that means. So example 4, we need to divide 34 x to the negative third, y to the second, z to the negative fifth. We need to divide that by negative 18 x to the negative 6, y to the second, z to the negative 2. Okay, so remember when we're dividing and we're dealing with all of the exponents and all of that, we're just going to make it a fraction. So 34 x to the negative third, y to the second, z to the negative fifth, over negative 18, x to the negative 6, y to the second, and z. So what's going to happen is we're going to go ahead, we're going to deal with the 34 and the negative 18 later. But for right now, I want to look at the quotient rule for all of these, okay? So for our x's, we have x to the negative 3 minus negative 6. Okay, and then for our y's, we have y to the 2 minus 2. And then for our z's, we have z to the negative 5th minus, and remember that's a 1, so minus 1. All right, so that means we have 34 over negative 18. And then negative 3 minus negative 6, that's negative 3 plus 6, which is positive 3. So now we have x to the third. And then y to the 2 minus 2, that's y to the 0. And then z to the negative 5 minus 1, that's z to the negative 6. Okay, so a couple of things. First thing we want to notice is that y to the 0 is 1, right? Y to the 0 is 1, okay? And then let's go ahead and reduce. Let's see, 2 goes into 18 9 times, and 2 goes into 34 17 times, okay? So let's see, we have a 17 in our numerator, and we have a negative 9 in our denominator. We have x to the third in our numerator, and we have z to the negative 6. Well, z to the negative 6, that's not simplified. Remember we said in order for it to be simplified, we want to write it in positive exponential form. So that z to the negative 6 needs to be moved. So it'll become 17 x to the third over negative 9 z to the positive 6. I just realized a small error. This right here was z to the negative 2, which means that this z right here in the denominator should have been z to the negative 2, which means it would have been negative 5 minus, it would have been negative 5 minus negative 2. And then negative 5 minus 2 is negative 5 plus 2, so it would have been negative 3, not negative 6. So that means that instead of moving z to the negative 6 to the denominator, we need to move z to the negative 3 to the denominator. So it'll become z to the positive 3 once it's in the denominator. All right, glad that I caught that. All right. Let's do some more examples so we can get really good at this. I want to do y to the x squared, y over x squared to the third power times x cubed y to the negative fourth to the second power. All right. So my directions for this example, and this is example 5, my directions are this. Simplify, but leave all variables in the numerator. So that means that if I get a negative exponent, that's okay. Leave it in the numerator. Okay, that's fine. Leave it in the numerator. Leave it negative in the numerator. Okay, so let's go ahead and try this. First thing I need to do is I need to distribute this 3. So that's going to become y to the third power over x to the second power to the third power. And I'm going to go ahead and just bring this down. So I still have x cubed y to the negative 4 all to the second power. So we'll deal with that in a second because we're still working here, right? Because now that's going to become y to the third power over, this is x to the second to the third, so 2 times 3 is 6, so that's going to become x to the 6th. Now that I've done that, I need to go ahead and distribute this 2. So now I'll have x to the third to the second, y to the negative 4 to the second. So this doesn't change, so this is y to the third over x to the 6th. And this is all being multiplied, so x to the third to the second is x to the 6th. And then y to the negative 4 to the second, negative 4 times 2 is negative 8. So that becomes y to the negative 8. Okay, notice that I have x to the 6th over x to the 6th. Remember, that's just 1, so that goes away. So now I'm left with y to the third times y to the negative 8. Okay, so that's a property. I just add the exponents. So y to the 3 plus negative 8 will become y to the negative 5th. So if I wanted to simplify all the way, I would move that y to the negative 5th to the denominator. But my directions say leave all variables in the numerator. So I'm okay. Let's do another example. We're going to start example 6. And in example 6, we just want to simplify. Okay? So we have negative 2 x to the negative 2 over, or times negative 3xy negative 2. And then that is all over 12y to the third. Okay, so first things first, let's multiply, right? Negative 2 times negative 3 becomes positive 6. And then x to the negative 2, and x, that's going to be x to the negative 2 plus 1, because remember that has an exponent of a 1. And then we have y to the negative 2 all over 12y to the third. Okay, so negative 2 plus 1 is negative 1. So we have 6 x to the negative 1, y to the negative 2, all over 12y to the third. Okay, well, we can use the quotient rule here. So we have 6 over 12, x to the negative 1, and then y to the negative 2 minus 3, because we're using the quotient rule. So now we have 6 over 12, x to the negative 1, and then y, negative 2 minus 3 is negative 5, so y to the negative 5. Almost done. Let's go ahead and simplify 6 over 12 because we know that's 1 over 2. Okay, so that's done. And then x to the negative 1, that wants to go in the denominator, right? So it can be positive. So now we'll have 2 to the x to the positive 1, which is just x. And then we have y to the negative 5th who wants to move. So it'll become y to the positive 5. And then that is simplified. All right, so let's do something very similar to that one. We're still example 6. We're going to do 8x squared z to the negative 3 all over y times y to the z to the negative 4 over 2x to the 5th to the negative 2. All right, so first things first, distribute the negative 2. So he's going to be distributed everywhere, to the y, to the z, to the 2, and to the x. Okay? So this, we're just going to keep him the way he is for right now. But I'm going to go ahead and draw one big fraction line. So everything in the numerator here will be in the numerator. Everything in the denominator here will be my denominator. Okay? So now I've got y to the negative 2nd power. I've got z to the negative 4th to the negative 2nd power. And my denominator, I have 2 to the negative 2nd power. And I have x to the 5th to the negative second power. So let's go ahead and take care of our powers to powers, right? We're going to go ahead and do these guys, okay? So in my numerator, I still have my 8x squared, z to the negative 3, y to the negative 2. And this is going to become z to the 8th because negative 4 times negative 2 is positive 8. So z to the 8th. In my denominator, I'm going to have y, 2 to the negative 2. And then 5 times negative 2 is negative 10. So this will become x to the negative 10. Okay? So now I have to see if there's anything that I can use my product property on, right? So let's see, product property, there's a z and here's a z. So we'll go ahead and add those z's together, right? So let's go ahead and do that. So 8x squared, and this is z to the negative 3 plus 8. And then I still have y to the negative 2. All over y, 2 to the negative 2, x to the negative 10. All right, so this will become 8x squared. Negative 3 plus 8 is 5, so this will become z to the 5th, y to the negative 2. All over. Let's go ahead and put these in order. So my number is going to become first, so 2 to the negative 2 power. X comes next, so x to the negative 10, and then y. Okay? So I have this negative exponent here, right? So let's go ahead and move him up. We're going to move him up. So 8 times 2 to the 2nd power. And let's go ahead and take care of this quotient property. So x to the 2 minus negative 10. And then we have z to the 5th. And then let's go ahead and take care of this quotient property. So y to the negative 2 minus, and there's a 1 there, so minus 1. All right, so 8 times 2 to the 2nd power is 4. And then x to the 2 minus negative 10, so that's going to become x to the 12th. And then we have z to the 5th. And then negative 2 minus 1 is negative 3, so it'll become y to the negative 3. We are almost done. Very last thing is to simplify it. We can't have a negative exponent. So in our numerator, we have 8 times 4, which is 32, x to the 12th, z to the 5th, all over y to the positive 3. Done. All right, that's all the examples I have for you. So you're going to do some problems on your own. You're going to do 8.2, 2 through 6 evens.